Every year, the marine insurance sector is faced with claims for contaminated cargo that cost tens of millions of dollars. The operation of chemical and product tankers is becoming ever more complex and sophisticated, brimming with design and technological improvements. Appropriate and often increased levels of training and industry guidance are maintained to keep pace with the developments. So why does cargo contamination remain such a persistent, costly and serious problem? Much of what is carried on tankers is of very high value, where contamination can result in an insurance claim exceeding the actual value of the cargo affected. This is not just a problem for an individual vessel. Any contamination claim has a knock-on effect throughout the shipping industry. But if better ship design is enabling more efficient and cost-effective operations, why does cargo contamination happen at all? In this video, we look at the types of cargo contamination, their possible causes and methods of prevention, the consequences and costs to the industry, and finally, what steps to take should it occur. Each of these subjects comes under its own title heading, with summary points to enable discussion and reference to the accompanying workbook. By definition, insurance claims are made where cargoes are found to be contaminated by something that should not be there, degraded in some way, or simply found to be off specification or off spec. So let's begin by defining common forms of contamination. Toward the top of the list is likely to be the previous cargo. Always ensure that all tanks, pumps, lines, drains and any blinds are thoroughly cleaned before taking on new cargo. Water is a common contaminant that can often find ways in through valves, leaking tank hatches and vents. Not such a problem with crude oil, as the water can often be settled out and removed without damaging the cargo. But water in ethanol, MTBE, methyl tertiary butyl ether, and glycol, for example, is serious and difficult to remove. Vapors of one grade of cargo can affect neighboring cargo by altering its specification. Inert gas and vapor relief systems of each product carried must be effectively segregated. Vegetable oil or any edible product must never be carried in a compartment whose previous cargo was in any way harmful to health. For confirmation of what is safely compatible, always refer to the NIOP, National Institute of Oilseed Products, and FOSFA, Federation of Oils, Seeds and Fats Associations, acceptable previous cargo list for vegetable oils. To give some idea of how serious cargo contamination is, consider some of the consequences. Tens of millions of US dollars in insurance claims are brought every year to cover the cost of cargo loss, degradation, reprocessing and refining a damaged cargo, or, in a worst-case scenario, the enormous cost of disposal. Reputational damage, the inability to access insurance cover, the probable loss of business, and the job security of their employees are all likely consequences of cargo contamination. Cargo contamination is very bad news for everyone. In the introduction, we've seen that cargo contamination remains a serious problem for the shipping industry. We've defined the meaning of the term, the common forms of contamination, the potential cost to the industry, companies, and your job. Prevention is always better than cure, so recognizing the risks and causes of cargo contamination is vital. The vessel is alongside, so let's first identify the shoreside risks. Whenever common lines have to be used by the refinery to transport product to or from their tanks to the ships,
twice more.
These could contain significant traces of whatever passed through in previous operations, if not properly cleaned. The tanks themselves, if not cleaned, could also contain residues from earlier cargoes that could affect their contents. Seawater can also enter the system from leaking subsea pipelines. There is also the possibility that contamination could be the result of impurities caused in the product manufacturing itself. While on board ship, there are additional specific causes of contamination that must be addressed. Tanks must be thoroughly clean before any new cargo is taken aboard. Tank washing can be achieved with washing systems using heated and cold ambient temperature, sea or fresh water, or approved cleaning chemicals if required. The correct line and valve setting procedures must be in place, and the ship's cargo lines cleaned and correctly flushed through with clean, fresh water whenever required. All pumps, tanks and lines should be thoroughly drained and ventilated dry. Salt and freshwater ingress is a constant problem that must be guarded against. All tank hatches, openings and vents should be maintained in good order and closed tight to prevent ingress of seawater and rain. The integrity of cargo systems must be maintained. Leaking valves and pipelines can be the cause of cross-contamination. Structural damage, however minor, could be allowing water to enter cargo, or, and more seriously, leakage between cargoes of different types. Any damage must be recorded and action taken immediately once detected. The tanks themselves can be the cause of contamination if the coatings are defective or incompatible to the cargo they hold, or even hold residues from the previous cargo within the coating itself. Contamination can also be the result of a failure to isolate the tank systems, especially where different grades of cargo are to be loaded. The pumps and pipelines to be used must be specified, and their use planned to eliminate the risk of contamination and cargo degradation. Segregation must be complete, and the components of tank systems maintained in good order. Temperature can have an adverse effect on products. Excessive heat can burn or scorch certain cargoes, such as palm or coconut oil, while cold temperatures can cause solidification. Other cargoes can degrade or change their characteristics and colour if their condition and temperature is not strictly monitored. Damaged cargoes often have to be sold as an inferior product at great loss. Even with all these precautions addressed, problems arise if there is a lack of information provided or made available. Make sure that all relevant information has been received and understood, and that the correct measures have been taken according to the properties of the cargo. But finally, there is one factor that can be more of an issue or dangerous than all previous examples: complacency. Vessels are likely to visit the same port facility many times, and the crew may get to know the terminal operatives well. But beware, familiarity can lead to complacency. Due diligence and rigorous attention to detail is essential at all times. In causes of contamination, we've looked at the most common causes, starting with shoreside risks, including common lines and tanks. On board ship, the cleanliness of lines and tanks, the effects of water ingress, tank condition and segregation, cargo temperature, good information. The danger of complacency that can be the result of familiarity with a port and their officials. So now that we know some of the causes and effects of cargo contamination, how do we prevent it happening? A first stage in any operation is to ensure that the vessel is suitable for the cargo intended.
Hi Chief, this is the Captain.
Hello, Captain.
Can you do the usual workout regarding compatibility and carriage requirement?
Send it through the email and I will work on it.
Thanks, bye.
Okay, see you.
The person in overall responsibility, generally the master, assisted by the chief officer, will need to determine whether the vessel is equipped to carry the different cargo types. Are the tank linings and coatings suitable, and of what material? Stainless steel, zinc, polyurethane, or other coating? Are the coatings in good condition and not showing evidence of decay, cracking, or blistering? If in any doubt as to the coating's suitability, the chief officer must always refer to the coating manufacturer's compatibility tables or manuals, and the shipper's materials safety data sheets, MSDS, for cargo properties. The chief officer also needs to know that the cargo temperatures can be reliably maintained in all conditions. The first stage of any loading or unloading operation is to prepare the cargo plan. Stage 1 is to ensure that there is no risk of cross-contamination by putting in place an effective plan for the use of pumps and pipelines, including the correct labelling of manifolds for connection. Cargo planning will take into account the temperature sensitivity of individual cargoes and avoid loading them next to or between tanks where there may be a significant temperature difference. Cross-contamination is not just a costly mistake, but can be highly dangerous, risking poisonous vapors, fire, or even explosion. The chief officer will draw up the loading plan, using the ship's safety management plan to provide a framework to identify hazards and control risks. With all pumps, manifolds, lines, blinds, drains and tanks prepared for the task, a final check should be made by the chief officer for any signs of potential leaks or faulty settings in the systems. The inert gas system is checked, along with pressure and vacuum valves. While in the cargo control room, all instrumentation and warning systems are tested. Sometimes nitrogen padding is required for sensitive chemical cargoes. Make sure that there is sufficient N2 supply on board for the voyage to top up and maintain the cargo tank nitrogen levels.
Okay, Chief, so this is the stove.
Yes, sir. I put it in 2 port, 8 port, and 8 starboard.
At the start of operations, the captain and chief officer must be in possession of all information, including details of terminal requirements and facilities, and how many shore tanks are involved. The terminals must also be informed of all details of the operation. A pre-transfer meeting will generally incorporate the exchange of all cargo data and facilitate completion of the ship shore safety checklists. The importance and benefits of having an adequate, properly prepared and fully understood plan cannot be overemphasized. And most importantly, emergency contingencies must be in place and everyone well prepared for any planned stops and what action to take in the event of any unplanned stop. In prevention and planning, we've outlined the key requirements needed to draft an effective plan of operations, starting with suitability of ship to carry the cargo, type of tank lining, their compatibility with cargo, risk of cross-contamination, temperature sensitivity, identifying hazards, machinery and alarm checks and tests, sufficient nitrogen stocks if required, loading plan understood by all parties, emergency contingency in place. A vital first line of defence in ensuring a clean cargo is the cargo inspector. The inspector's role is to monitor and sample the cargo quality at all stages of the operation, and they will have taken samples from the terminal tanks and possibly lines before the ship even arrives. As cargo inspectors are employed by the cargo owner or shipper, they are not there to represent the interests of the ship. It is important that all intended aspects of the operation are discussed between the ship and cargo inspector. The ship should use this opportunity to clarify any particular requirements that the cargo owner may have. Contamination can easily occur to a cargo before coming aboard. A possible cause, for instance, can be the residue of a previous cargo remaining in the terminal's lines. The master or chief officer should request or even insist that the cargo inspector gathers any additional samples required by the vessel from the terminal end before operations begin. All samples should be given a visual inspection to help establish quality before being sealed and initialed by the inspector to prove authenticity. If it is felt by the ship that the samples need more detailed investigation, the surveyor should be requested to arrange for them to be sent for further laboratory analysis. In the chemical trade, sensitive and high specification cargoes are common. These often require a process of line flushing and wall wash tests, all to be analysed before loading commences. These sensitive cargoes also demand a greater level of sampling. Ships should not hesitate to take their own samples. This precaution is very important in the event of a claim, in order to be able to verify the source of the contamination and protect the ship owner's interests. On board ship, a similarly rigorous inspection is carried out, collecting representative cargo and manifold samples. A final word of caution, though. One must be aware that depending on the cargo, taking samples can be dangerous. Vapours or spray from the product may cause poisoning, burns or scalding of personnel. Release of small amounts of products may cause problems. For these reasons, it is essential to strictly comply with all safety regulations and the advice and requirements of the MSDS. When commencing sampling operations, it's essential to ensure that the sampling equipment is clean and fit for purpose. It's important that sampling provides an accurate history of the loading operation. It is not enough to have a before and after sample. A lot can happen to a cargo during operations. During the sampling, the cargo inspector should be accompanied by a ship's officer at all times. It is also strongly advised for the officer to keep a log of all sampling, as differences of opinion may arise and good record keeping will be needed in the event of any cargo claim.
That's looking good, looking very clear. Go ahead with
It's recommended that a suitably sized sample is taken at the start of loading, followed by further samples taken regularly throughout operations, until completion. Where first foot samples are required, usually with chemical products, it is recommended practice that a slow loading rate is used into the first tank and that a first foot tank sample is taken for laboratory analysis. Further samples should then be taken at middle and full tank. These samples must be visually inspected, initialed, recorded and sent for analysis if there are grounds for concern. The labels of the cargo samples must at least contain the following information: the name of the vessel, the port of loading, date and time of sampling, the type of cargo being handled, operational status before or after loading, which tank the sample has been obtained from, what sample type, bottom, middle or top, the seal number for the sample, the name and rank of the sampler, and finally, the signature of the chief officer and, where possible, the cargo inspector. In addition, a sample receipt must be retained by the ship for custody transfer purposes. Once all parties are satisfied with the analysis results, full cargo loading can commence.
Stop popping, stop popping.
A representative set of matching samples must be retained on board to protect the interests of the ship. The ship sample should be retained in a dedicated, secure, cool, well-ventilated location that is not subject to extreme temperatures, as this may affect the quality of the material being stored. On chemical tankers, incompatible cargo samples should be kept apart. But what happens to the samples that are taken off for laboratory analysis? Some contaminants may be evident by actual particles floating in the sample, colour, water separation and changed viscosity. Where contamination is more difficult to identify, the samples can be subjected to more scientific procedures such as simulated distillation, trace analysis and chromatography. Usually, results can be obtained within hours, but in some cases this can take days. The resulting delay is extremely costly and could mean that the vessel is taken off hire and has to be moved from the jetty or berth and taken out to an anchorage before being given clearance to resume operations. Cargo contamination has an escalating effect, setting off a chain of knock-on effects if not immediately brought under control. So be diligent at all times, spot the contamination as soon as possible, and keep the damage to a minimum. The vessel is loaded, and steps must now be taken to safeguard the cargo in preparation for the voyage. On deck, a thorough check to ensure that valves, manifolds and hatches are closed and secure. The chief officer must ensure that the charterer's instructions are being followed. In the cargo control room, all inert gas pressures and cargo temperatures must be monitored, and it should be checked that those monitoring systems are functioning correctly. Additional checks must be made in advance of and after adverse weather conditions and logged accordingly. At sea, cargo temperatures must be monitored appropriately, as sea and air temperature can vary considerably during the voyage, and some cargo types are especially vulnerable. Certain cargoes can suffer irreversible polymerization or solidification if not kept at a stable temperature, or cargo-specific instructions are not followed. This could result in the ship having to be taken off hire to have the solidified cargo removed. On deck, regular checks must be made to ensure that there is no leakage occurring from manifolds or heating systems, that hatches and openings remain firmly closed. Regular checks should also be made of tank hatches to look for vapour escaping when at sea. If vapour can escape, then water can enter the tank when green seas come onto the deck. In gathering information, we address the importance of evidence in safeguarding the interests of the ship, looking at the role of the cargo inspector, sample taking at the terminal, sample taking on the ship, correct labelling and storage, the laboratory, preparing the ship for sailing, monitoring cargo temperature at sea, and checking for any water ingress or leakage. So far, we've concentrated on good practice and the avoidance of cargo contamination. But what happens when a problem arises? A vessel has berthed and prepares to begin operations. The cargo inspector comes on board and samples are taken to ensure that the cargo quality has been maintained.
Yeah, I think, Chief, we've got a bit of a problem. I can see some particles in there. I think that needs a bit of further analysis.
A visual examination of a sample shows that there is contamination present that requires immediate action.
Yes, Chief.
Good afternoon, sir. The manifold sample is showing signs of contamination.
Okay. All right. Can you ask the surveyor to do a resample and then revert back to me if it's still the same? And I'll give the operator a heads up. I'll call him now.
The chief officer halts all operations, alerts shoreside facilities, and orders an examination of lines, pumps, associated machinery and settings, taking further samples at the same time.
I'm calling in because one of the cargo parcel has a problem. The cargo sample has gone off spec.
The chief officer or the master informs the owners and probably the P&I Club. Depending on the severity of the contamination, the P&I Club may well appoint their own surveyor to take additional samples. In very serious cases, insurers will seek additional advice from consulting chemists and lawyers. All is put on hold until the master receives clearance from the owners to resume operations. When contamination is confirmed, depending on the individual cargo, what options are available? Firstly, if contamination is mild, it could be blended with clean cargo to dilute the contaminant to an acceptable level, in accordance with the advice of experts appointed by the charterers, shippers, and/or P&I Club. If the parcel of affected cargo is small enough, if permitted, it could be temporarily transferred to the vessel's slop tanks for treatment or disposal at a later stage. This solution will naturally impact upon the ability of the ship to perform as intended. The affected cargo could be transferred to a barge or coaster for disposal. And if the shore facility is prepared to accept the damaged cargo, it may be transferred to shore tanks. Apart from the first option of dilution, all other options may represent considerable costs. And it could get worse. In the chemical trade, cargoes often go directly from the ship into a production process. So any contamination issue could delay the offloading of the cargo, even causing, in an extreme case, the shutdown of the plant. This scenario would almost certainly result in a potentially huge claim for consequential loss. Seafarers are a professional workforce where good practice should always be followed. So none of these losses need happen. Be vigilant at all times and make cargo contamination and even cargo loss a thing of the past. In responding to contamination, we look at what measures have to be taken when something goes wrong. Contamination is detected. Operations are halted. Owners, charterers and P&I Club informed. What solutions to deal with contaminated cargo? What can result? In this video, we've identified some of the common types and causes of contamination, how it can be prevented, what measures must be taken to protect the vessel's interests, and what happens when things go wrong. Cargo contamination is not just a problem for the customer. It affects the whole shipping industry, and that could mean your job. Watch this video again, study the accompanying workbook, and you can help to stamp out this serious problem and keep your job safe.